What's up, nerds? Today we are looking at efficiency in the energy unit. And we think of efficiency like this. When we do any process in life, when we drive a car, when we lift something using a pulley, when we go up in an elevator or push something up a ramp, some of the energy in that process is wasted as heat. We can find the efficiency. So the efficiency is how much energy is not wasted by comparing the useful work output with the work input. So for the car, for example, the car consumes energy from gasoline, and some of that energy goes to pushing the car forwards, to accelerating the car, which is useful. It becomes kinetic energy. That's the useful energy. And some of the energy is wasted by heating up the motor. It's wasted with friction with the ground and the bearings of the wheels of the car. There's lots of wasted thermal energy that is not useful. So the efficiency is the percentage of the work that is useful. Now there's two ways to look at the output versus the input. First, we can compare the total useful work output with the total work input. Secondly, we can compare the work output and the work input per second. And you may know, or if you don't know yet, you will learn in your physics class that the work output per second is called power. So work per second is measured in watts, and that is a power output or a power input. So looking at the total work output and total work input, or looking at the output versus the input per second, we can find the efficiency. So one more note, efficiency can be shared as a decimal or a percentage. So it can be 0.75 or 75% efficient. Those are two ways to represent efficiency. Now, here's an example that we're going to use to look at efficiency. We have a 950 kilogram car, and it uses 150,000 watts of power from the gasoline in the gas tank to accelerate from 10 meters per second to 26 meters per second in 3.7 seconds. So let's say you're merging onto the highway, you have to accelerate, you push the gas pedal down, you accelerate really fast so you can merge safely onto the highway. We are asked what is the efficiency of the car and how much energy was wasted as heat. So let's start with part A here. In part A, we want to know the efficiency. Now, a tip for you, if you see watts, this is W represents watts, which we can measure in joules per, a watt is equal to a joule per second. It's the measurement of power. Or if you see seconds, a measurement of time, you're generally going to want to use this formula here instead of this one. You can ignore this middle part. I was just using it to make a point. So we can use efficiency as power or efficiency as work. Now, if you see seconds in the question or watts in the question, I recommend you start with the power formula, because if time is involved, you're going to end up using power at some point in the question. So let's write down our power formula. Efficiency equals P out over P in. Now let's read the question carefully. Let's think about what we have here. The car uses, it's a 950 kilogram car, it uses 150,000 watts of power of gasoline from the engine. And that is our power input, is 150,000 watts, because that's the energy being supplied to the system. And our power output, well, this is whatever is the useful output. So what do we want the car to do? We want it to get kinetic energy. So the power output is going to be the work output over time. And you may know work is equal to a change in energy. So the work output in this specific case is a change in kinetic energy over time. Now the change in kinetic energy over time Well, change in anything is just final minus initial. So EK final minus EK initial gets us the change in kinetic energy. And we can expand this even further. We can say EK final is 1/2 m V final squared, and EK initial is 1/2 m V initial squared. So here is an expanded form of the power output. It is the change in kinetic energy, which is all of this. This is the change in kinetic energy of the car divided by time. Okay, let's find what this is, and then we'll plug it back into the efficiency formula afterwards. So this is 1/2 times 950 times 26 squared minus 1/2 times 950 times 10 squared. So 10 is the initial velocity. And our time is given in the question as 3.7 seconds. And we might use this value later, so I'm going to tell you what the change in kinetic energy is. That's the top of the fraction here. This is 273,600. So that's the change in kinetic energy divided by 3.7. And that divided by 3.7 is 73,946 watts. So this is our P out, our power output. That means the car is gaining 73,946 watts, so that many joules per second of kinetic energy. Now we can go back over here and finish our equation. So the efficiency equals 73,946 divided by 150,000, and that is equal to 0.493, and we can also give this as a percentage, so 49.3% efficient. Okay, that's part A. Part B says how much energy was wasted as heat. If you'd like, you can pause the video and try and find it yourself. If not, let's do it together. So for part B, we want to think not of how much energy was useful, but how much energy was not useful. And to look at this, we can think about the efficiency another way. So let's say out of the 100% of energy that goes into the car, we take away 49.3% of it. That leaves us with 50.7%. This is the percentage of energy that is wasted, because if it is 49.3% efficient, it is 50.7% not efficient or inefficient. So this is the wasted percentage of the energy supplied to the car. A little over half the energy is wasted. So let's think about the total energy that the car gets. And we can find that by going 150,000. Here, let me explain further. Power equals work over time, or change in energy over time might be more appropriate here. So the total energy supplied to the car from the gasoline is P times T, which is 150,000 times 3.7, which is equal to 555,000 joules. So in the 3.7 seconds, this is the total work input into the car. Now of the total work input, we know 49.3% was useful and accelerated the car. And we know of this, 555,000, we know 50.7% was wasted. So we can say 0.507. We can multiply by 0.507 to get 57%, and that's equal to 281,385 joules. So this is how much energy was wasted. as heat. So this went into heating up the engine or friction with the road. This is energy that did not accelerate the car. And let's compare that with this value here. This was the energy, just for comparison, 273,600 was the useful energy. This was the delta EK. So if this many joules was useful, 273,000, and 281,000 was wasted, sorry if you can hear my dog, my apologies, we can see that a little over 50% was wasted and a little under 50% was useful, which supports our calculation that we are 49.3% efficient. All right. Thank you for listening. I'll see you next time.